let's see. This is the Portland Linux Unix group. Who's been here? Who hasn't been here before? Yeah. Have you not? You've been. Have you come to these? Oh, so introduce
I
yourself.
just look like everyone else. Yeah. Well, my name's David Miles. I just recently moved here from the San Francisco Bay Area.
Oh, okay.
About 9 months now. Took the train to get here. Got here 3 hours early, so I've already seen this room. I've already seen everything down here. So, anyway.
You just got here today.
Yeah, today. Well,
You
no,
you took the train up here just for the plug talk.
Absolutely. I
That's
had
impressive.
extra time though, so I
Yeah,
went to other
sweet.
places. So
So wait a minute. Are you like staying here? Or you're just here for a?
No, I moved here.
Oh, okay.
Yeah, I live in Hillsborough.
Okay, nice.
You found a speaker?
Yeah, exactly. Yeah, it's yeah.
Well,
We're coming to
Linux,
that.
I use Unix. I have a lifelong experience with Linux. And
Yeah.
Unix. Windows not so much, but I did make money supporting that at one point.
Nice.
That's pretty much it.
How did you find out about the meeting?
I just went to a search engine and typed in Portland user group, and you popped up.
Sweet.
Was that
Might have been a-
Alligator or
No, I think it was on DuckDuckGo.
So it might have given you a link to Calgator or possibly to our website. It's hard to say.
kind of a local events, tech events?
Yeah.
Kind of calendar thing?
Well, I'm sort of like that kind of thing that leaks everywhere, and eventually the gasoline gets in somewhere.
Anyway, Calgator's kind of an awesome local resource. If you're Cala, C-A-L-A, and then Gator, G-A-T-O-R. Yes, exactly. Put together by
Alligator.
local nerds long time ago. It's still
Local
clinging to life. There have been a few issues recently, but they were all smoothed over and fixed.
Yeah.
Anyway, it's before the pandemic in particular, the thing was just chock-a-block with events. And since the pandemic, it's been gradually coming back to
There
being more
was a lot
saturated.
of meetings during the pandemic
No,
shutdown.
not that many.
Yeah.
Okay, so I have some news items, or some items to run through here before we get started. First thing is we need speakers. We have a speaker tonight, awesome, because my planned speaker, what the hell was his problem? Oh, last month he got sick, so he couldn't do it last month. And then I said, hey, you want to do it this month? And he says, I can't because I got some scheduling conflict. I said, how about June? He said, fine. And then I reached out to Loren, and which he had said he had a topic to talk about. So we got him tonight. And then we hopefully have Jesse Lopez next month, if everything works out. But after that, I got nobody. So if you got anything vaguely interesting, anything you're vaguely excited about, anybody that has or starts bending your ear about something that sounds kind of interesting, that they're clearly excited about, have them contact me, and we'll get them scheduled on one of these talks. Because otherwise, we'll have sheer boredom.
You almost reverse it though, and basically ask everyone here what they're interested in, and then
I've done that.
Find a speaker and we'll address it.
Yes, or bar the door and not let them out until they've committed to something.
Yeah, there you go. That always works.
Yeah.
Of course.
Second news item is we as of a year ago or something, we started having the monthly Linux clinic again after doing it for decades and then not doing it during the pandemic. We normally have Willamette University has a Portland campus, which is half a floor of a building in Northwest Portland. They actually also have PNCA, so they're all, because it's Willamette University. They've been hosting us for the clinic. However, this month we're going to be at the Albina Branch Library in Northeast Portland. I think it's still northeast there. It's on Russell Avenue. It's got a nice big room with big glass wall that people walking by can see us, which is why I kind of like having clinics there periodically, because there's foot traffic that goes by and they say, who are those weirdos in there? What are they doing? And maybe I need help too, or I can tell somebody who might need help and they can come. So that's this month is I don't know what the hell the date is. Is it the 18th? Something like that. 17th. It's whatever the third Sunday is. 1 to 5 p.m. We usually have a medium-sized turnout. Some people need help, and some people are there to help other people, and it's kind of fun. And you can just hang out and work on stuff, while you're waiting for somebody that needs help. The following month, I am actually out of town, and we also coincidentally don't actually have a fallback venue at the moment. So Willamette is normally super reliable, and we can always go there. But to get the library, I have to be super punctual and reserve it within 15 minutes of the reservation opening up, which happens 30 days beforehand. So I have it for this month. I don't have it yet for next month because I won't be able to do that until May 22nd or something. We don't, but Willamette is off the table in June because they're having an event that's going to use the whole space. So, so I've been trying to draft Ian to be the host for the June one because, again, I'm going to be out of town that weekend. So anyway, TBD as far as what's happening with the clinic in June, but we are having one in May. I put a little news item down here. Who's heard about this copy fail thing? Who's checked their computers to see if they're vulnerable? Who hasn't checked their computers to see if they're vulnerable?
Everyone, Slackware plugged. Slackware is not vulnerable.
There's a new one. There's Sturdy Frag now.
Oh, really?
Yeah.
Is the same people?
That's why Slackware last.
Yeah. So I'm going to just tell you my little anecdote. I was checking a Debian box, and I ran the little exploit script they helpfully provided, and it didn't work. And then I logged out. I said, "Oh, we're good to go. I can forget about this one." And then, 3 days later, I log in, and I need to get root, so I type su. Boom! There's a little. What the hell was that all about? So I had updated the kernel. I rebooted. Everything's fine again. But that was a little surprising.
That explains why my distribution updated itself 3 times in 3 days.
I was a little surprised that, apparently the distributions didn't get the early disclosure because they weren't ready. Why had they not shipped the thing already? The kernel people clearly knew, but the Ubuntu, Debian, all these people are like, what? Yes.
I think that's shocking. Just imagine when somebody gets the open source of the kernel and runs it through Mythos.
Well, kind of that's what they're doing, yeah.
They've already done it.
Yeah. Any other news? Michael was asking about Linux Fest Northwest. Who went to Linux Fest Northwest? You want to give a brief report?
Brief report. All right. Well, it was fun. Lots of good talks there. Lots of good vendors too. I'm a hardware guy, so I had to play with the framework laptop and the new System 76 laptops. We have some other guys there as well, but it was a friendly group of people. If you didn't go, you should go. It's not that far from here. So a lot of good talks. A lot of talks on the ham radio talk was fun.
Ooh.
About that, and then they had some talk about on security, some certificates, the secure boot, and so forth. And
Yep.
Did they have SDR demonstrations there?
no, he did not. He just had talk. So
Was it the HamWAN people or whatever it's they have a Puget Soundy mesh thing?
No, I don't know. It was a long time.
No. This
It was
is
a
a
long time
Wi-Fi
guy that
thing.
was there. It wasn't a Mestache guy. I can't remember his name right now, but you can see his videos. They all have all the videos posted.
Yeah.
I'm getting old. My memory's not so good anymore.
So the hams, they have a
talk to
tendency.
people.
They tend to have a tendency to get up in tall mountains with repeaters and stuff. And the same crowd of people said, "Hey, we could be pointing Wi-Fi stuff with parabolic dishes at other towers and do a mesh out of that." And I think they started up in the Puget Sound area, but they've expanded down at least through the Willamette Valley as well. and I incidentally intersected with them a little bit, but not very much.
Yep. We also have Arden down here.
Yes.
So, in fact, we have Arden on each of our campuses at Intel, so it's pretty cool to be involved with setting up an Arden wireless network.
I went to some event that was out at the Portland Emergency, whatever the hell it is, out on Kelly Butte, and they got a tour of the building, and they have an antenna on their roof that points at like OHSU, and I think there's something on the Portland building or something. They have some, the idea being when the earthquake happens and everything falls down, that somehow that they're going to have channels of communication, whether that works or not, who knows. After this event, and after Michael brings me 8 terabytes of old videos, we meet after this thing. There's a bar down on a street. It's First and Yamhill.
Yeah.
You can just wander around. See if you see lights, just knock. It's called Patty's. You have to be 21. If anybody, by the way, isn't 21, wants to come to one of these after things, let me know and we can find a minors friendly environment. And does anybody else have anything to mention at all? Your great talk idea? No? Okay. And with that, I think we're ready to go. So away we go.
Okay. So as you've probably figured out, my talk tonight is on secure boot and how to deal with that, especially with our now expiring certificates. That's coming up very quick. So this is a very opportune time for this talk. This talk will be somewhat information dense, and because it can affect, a lot of you might run into this, do let me know if I'm going too fast or you have questions. I'd rather have you understand something from this talk than just hear a bunch of technobabble, even though we are all geeks here. And with that, I do realize secure boot is kind of a contentious talk around this kind of crowd. So I thought I'd mention a few reasons why you might like it. I mean, some of you might actually think it's a good idea, and that helps prevents rootkits and all that fun stuff. But you also might just have to seamlessly boot Windows and Linux, and you might be one of those guys that needs it for Windows because of anti-game cheat or something where they require secure boot and it won't work. So you want to have Linux be happy with Windows. Or you might be at a company that has a corporate IT policy that says your laptops must have secure boot if they leave the building. You might not be able to turn it off on some devices. That's the case, or some combination of all of that. So I have to deal with several of those reasons myself. So with that, there's some important disclaimers we need to start with. First off, this is a good time to remind you, back up all your important data. I don't care what. You should do this regardless. I have my work desktop at Intel one day stopped responding to my commands. I couldn't log in. I came and found the firmware had died in the controller of the SSD and lost its configuration. It had no idea how many flash chips were inside of it. And I could not get to, I had to throw the drive away and get a new drive. So I had to luckily restore for backups. But the second reason is if you have any kind of disk encryption, especially with Windows with BitLocker or Luke's, you might have a master key. Make sure you know what those are and that you can mount all of your partitions without requiring your TPM or anything else working. So with BitLocker, there's generally a recovery key you can get. So either it's synced to your Microsoft account or somewhere, or IT will know how to give it to you, or you will have a way to get it on your own computer. But you want to know what your recovery key is, because you likely will need it during this process. And the reason why you will probably need it is if you have that automatic disk unencrypt or it unlocks your computer on a normal boot. That uses a feature of the TPM. The TPM measures your system state, and if it thinks everything looks good, it will unlock certain keys for you, like your disk encryption key. One of the things it uses, they're called PCRs. PCRs are basically a big fancy hash. They hash a bunch of data, and if you get the same hash, you're okay. If the hash is different, it won't unlock your system. One of the things it hashes is PCR7 will hash your secure boot state. So if you update certificates and you don't update your corresponding BitLocker setup, you will need a recovery key on your next boot. That scared me the first time I did that to my corporate laptop. I did not want to have to call IT and figure out how to unlock my laptop again until I was trying to install Linux on my Windows provided laptop. So, but luckily the BitLocker key recovery key is all I needed, and it just worked after that. But I didn't realize what I had hit. It was because I had changed my secure boot state, and it lost the ability to unlock my Windows drive.
Question?
Yes.
Do you know what PCR means? Stands for?
Platform Configuration Register.
Gotcha.
So it's designed to measure the state of your platform. There's a PCR that hashes all of your firmware. There's a PCR that hashes all of your option ROMs. So if you use that PCR as one of your BitLocker PCRs, you can add in a network card, and now you're going to do your BitLocker recovery key. So you want to be careful which PCRs you select. PCR 7 is usually one of the ones they will include for BitLocker. So if you turn off secure boot, you'll now need your recovery key to mount your Windows computer, even if Windows otherwise won't care about secure boot. And you can use TPM2 for Luke. So some people might do that because they want Linux to do the same thing that Windows does and just boot without requiring a password. Just make sure you can recover your data before you play with your secure boot state. So here, the most important key takeaways from this talk is most computers that have secure boot, and in fact right now, definitely any computer that has secure boot enabled will have the 2011 certificates as one of their primary certificates. And those will start expiring next month on June 24th. And there's a newer set of certificates that came out in 2023, so they've been out a few years now. The goal is to update to those certificates so that secure boot will continue to function as we go past June. But most importantly is Microsoft in their blog, and I put a link to the blog where they claim that. So by the way, I have a bunch of links down here. The goal is you're not going to read them here, but I can give you send this presentation, on the email chain or whatever. You can get the presentation and click on the links and see the backing information from what I'm talking about. So Microsoft says it won't break secure boot. It won't break the booting of any computer that has secure boot enabled. What it will do is anything produced after the expiration will only be signed by the non-expired 2023 keys. So, for example, even on Linux, if you update your shim and the shim part of the bootloader, that will need a newer key if you have a newer update for Ubuntu, as well as Windows and so on. Anything that has a newer update of that will have to have the newer key. Otherwise, it won't be able to approve it. So you're only blocking OS updates, basically, that are required for secure boot. But systems will still boot. Also, as long as you have the 2011, what they call KEK, I'll explain that. As long as that is installed, which is the original one that you would come with normally, you can always upgrade to the 2023, even if your motherboard is not supported. And I'll go into that a little bit later. So ideally, you'll use the standard mechanisms to upgrade, but if not, you can always manually apply the updated keys to the 2023 keys to a 2011 system. So there's a lot of keys involved, so I think it's good to kind of understand the chain of trust. There's 3 primary databases you will see for all of your secure boot keys. The top of the entire chain of trust is what they call the platform key. This is a key that is used to approve any updates to the platform key itself or to the key enrollment key, which is what Microsoft controls. The platform key does not come from Microsoft. It comes from typically your motherboard vendor, or it can be replaced by an enterprise or even yourself. You can put your own platform key and then approve your own updates if you don't trust your motherboard vendor to do it. So that is the ultimate root of trust. The key enrollment key is there just to manage the signature updates so that Microsoft can give you updates as they produce newer databases. So the actual databases that have the keys that sign your bootloader are in these signature databases, DB primarily. DBX is used to record a list of known insecure bootloaders that have been compromised, and they were signed previously and now need to be revoked. So these two are the primary things that Microsoft will regularly give you updates for, and all of these updates are signed by Microsoft, by Keck, and if you have Ubuntu, you might potentially have updates from Ubuntu and others that go in there. But ultimately, this signs the keys that allow your bootloader to go boot itself. At that point, your bootloader can add additional keys in, which is how you get your own keys. So for your NVIDIA driver that you have to compile from source or whatever. So you can have additional keys beyond the bootloader keys and the standard database keys that Microsoft provides.
Question? Where are all those stored?
I'm going to show you that.
Excellent.
So just to get the names out. So the key and Roma key, this is the top level of what Microsoft controls. They have two, the original 2011 and then their replacement. So all they did is they just, have this one is expired in 15 years. This will expire in another 15, basically 12 years from now. So 12 years from now, you'll have this all over again. Even though it's good for 15 years, they seem to have a 3-year overlap. So every 12 years, you have to update your secure boot state, or your system might start breaking.
Question: who needs to update that? Because I suspect that most people, even in enterprise environments, don't work with that. So who's responsible?
No. I had a meeting with my IT that told me that I need to update all my systems.
Okay.
So no, I'm having to do this at work right now to keep my system IT compliant and on the corporate network. Because and that's true. My Windows laptop as well as my Linux system. If I don't do these updates, what happens is at some point my bootloader for Windows will no longer update. Same with Linux, but especially with Windows, they will definitely care about that. That you won't be able to get the latest Windows 11 bootloader because it's signed with the newer key, the latest Windows kernel or whatever. So these will definitely need to be regularly updated. Normally, there's a service that Linux has that will do this, and I'll show you that a little bit later. And Windows, there's a background service that will do these updates on its own on a regular task. So there's two kecks, the old and the new. There's 5 DB keys, but they're really 2 categories. There's the 2011 ones here and the 2023 ones. Initially, they provided 2 of database keys. The original one that signs Windows stuff and the one that signs everything else that needs to boot in UEFI. So this key is what signs Linux, your option ROMs, or anything else that needs secure boot to load during the pre-boot state. You'll find that all of the Linux bootloaders at Red Hat or Debian, Ubuntu, Canonical, they all have a key signed by this to support their bootloader. That's replaced by, the Windows one is called, this is the new one for Windows. This is the one for option ROM. So decided option ROM should have their own key, so that way they can disable all the third-party OSs but still allow option ROMs to work in secure boot. So they have 3 root keys now for all firmware: Windows, option ROM, and everything else. So in theory, you'll have, once you're done updating, you should have all 3 of these lower ones, and you should have the 2023 KEC. You'll probably still have the old ones too, because they don't want to break anything right away, not until they expire. Just some other terminology here. When you're running in secure boot, you'll find somewhere in the BIOS it'll tell you you're either in setup mode or in user mode. Setup mode is when you first turn on secure boot, but you haven't loaded a platform key yet. So an older motherboard might come this way, or you might be able to reset back to setup mode if you already had secure boot enabled when you got the machine. Basically, removes the platform key, and you can load whatever you want. So at this point, it turns off all authentication. You can load in your own key. So if you don't want to trust your Lenovo or motherboard Bender, you can choose to completely remove that and create your own chain of trust. User mode is any time secure boot is being enforced. Once you're in user mode, you can only update these databases with signed signature list. But you can generally go back to setup mode in the BIOS with some reset or something. Deployed mode is when they really want to lock it down. I've never seen this, luckily, in the wild yet, except I think Surface RT might have been deployed mode, because you couldn't, at this point, the only way to leave deployed mode is with a signed update from the platform key. So that's when they want to really lock the system down and don't want the user to ever turn off secure boot. And audit mode is here there just to validate this before they actually lock it. So normally these two modes you won't really run into. You'll either be setup or user mode for any system I've ever worked on. So ultimately where these are stored are variables in the UEFI variable database. And you can see all of these variables. So the PK, and you can have multiple platform keys in theory, I think multiple kex, db. So these are all variables that you'll find on your system. And if you have the shim bootloader, you might have mock variables. These are used for things like when you have your NVIDIA, your machine mock, by the way, is machine owner key. So that's the key that you generate as the owner of your laptop because you want to sign your NVIDIA driver and have it loaded, or you want a custom kernel. You don't want to use one of the stock distribution kernel. So you need to load a key into the mock, and the shim will accept everything there in addition to these other lists. So let's start with the demo here. Let's actually,
Can I just, quick clarification, where does the EFI vars actually live?
I'm showing you that right now.
Excellent.
That's what this demo is. So,
Okay.
first of all, is the font big enough, or do I need to, I can make it a little bigger?
A little bigger.
Okay. Is this big enough?
That's good.
Okay. So, first of all, I'll do mount grep-i EFI. You'll see there's a file system mounted on my system. This is standard on most modern systems if you installed it as a UEFI boot OS. So you can actually see the variables, and you can always mount it later only if you boot it in EFI mode. If you're in legacy BIOS, you won't see this. There's a file system called EFI vars, and there's all of my variables. Let's see here. Actually, let me do a, let's see. Oh, come on. I'm just trying to just show you the volume. Okay, even that's still a lot of variables. Okay, but
Is that on the partition of the disk, or is it?
no, this is in flash memory somewhere on the motherboard.
Okay.
This is non-volatile flash, non-battery backed memory. Pulling your CMOS battery will not clear these variables. So if we look here, we'll look for PK, and there it is. You'll see actually there's PK, that's the real database, and there's also PK default. So in the BIOS, there's a section, reset my secure boot keys to default or system platform, whatever they call it. That's what the default list is. So that's the original 2011 key. And you'll see, all of these are here, KK, there's the KK in the default. You'll see DB, and you'll see DB and DBX are both in there. So they have the default that from your last BIOS update, as well as what my current state is of that variable. So everything about secure boot state, in fact, there's a variable here called secure boot. And if I cat this variable and just run it through a hex dump real quick, you'll see the last byte is 1. That's that says it's enabled. So that tells me I have secure boot enabled on my laptop here. And there's a variable called setup mode. You can see it's a 0 at the last byte. So I'm not in setup, I'm in full user mode, so secure boot is being enforced. And
Max limit to how many variables?
yep, and you can run out of space. So that is one concern, that if there's some compromised bootloaders out there that have been released, that they're signed by a key that is trusted by a lot of other bootloaders, that's also good. And there's a concern that about revoking them, you'd have to revoke a whole lot of subkeys, and they could overflow the space you have for these variables. So there's a small amount of space somewhere on your motherboard for all of these variables.
How much space do you have usually?
I think it's in the megabytes. I don't know if I had it.
1K it says available.
Yeah, I'm not sure how accurate this is, but it is. It's in a matter of megabytes at most, I think. It's not a big space.
100K.
But one thing you'll see here, if you look at attributes, you might recognize I as being immutable. So some of these variables I can modify from my OS right now. Other ones I cannot. Like I cannot modify secure boot, even if I try. The UEFI will block me from modifying that part of the variable space. I can only do that while I'm in the BIOS menu. But yeah, all of the stay here. If I actually wanted to code this, I can go EFI-readvar, and I can look at PK. And you'll see here, I have, my platform key is IdeaPad Products from Lenovo, basically. That's the original one. Let's see here. As far as KEK, this is the one that'll be the Microsoft key. I am still on the 2011 keys. You can see right here. I haven't updated my system yet. And then my DB, there's a few more keys here, but you'll see what's interesting is I have no idea where, but this is the way I got my laptop, that it had Joe's Software Emporium included in there. But you could also see that the other two keys are the standard third-party OS and the Windows key. So these all came with my system when I got it. The tricky part is I can't revoke that without having a signed key by a KEK, which right now I only have the Microsoft key. So I'd have to actually go in, disable secure boot, and load my own platform key to revoke Joe's key if no one else has revoked it. So I've not taken the steps yet to do that on my personal laptop.
But if you revoke it, it doesn't delete it out of it, right? It just
This variable I can modify as long as I have a signed chain of trust. So,
You're not really revoking, you're just deleting.
well, I can actually, yeah, this variable I can literally delete out of it. But more correctly, what I would probably want to do is add it to the DBX. So if it ever gets added, because if this was ever signed by Microsoft, I don't know if it was. If it was, then they could potentially re-add it with a Microsoft update.
That probably came from like an imaging program.
Yeah.
Virtual imaging program.
What I have seen with a number of platforms is oftentimes you'll have like a Lenovo platform key, and then in addition to the Microsoft KEK, you'll have a Lenovo KEK and a Microsoft DB certificate. So your motherboard vendor can also install their own secure boot operating systems, not signed by Microsoft. Another program that's nice is MockUtil. Sometimes this is a little easier to read. This actually decodes their certificates in the, if you're used to OpenSSL, you can see it in SSL, the typical format that they show. But this is what the Microsoft root KEK looks like. And
The expiration date on there.
yep. So the expiration date you can see. Yep, June 24th, 2026 is when that. So 15 years is all it's good for. So at that point, I won't really get any more updates.
So it's using your system clock to figure out what the date is.
It's not so much that. They actually don't rely on the clock because that would, so unlike traditional certificates where the moment you expire, it's useless,
Yeah.
that would break a lot of systems. So I think Microsoft has chosen not to do that. In their blog, they're clear. What it breaks is signatures. So when Microsoft uses their KEK to sign another DB or they sign another bootloader with their DB certificate, they will use the current date of the signing, and when they start signing with it after June 24th, that signature can only be valid with the newer certificate. So you will have things that are signed by a key that, because the other key wouldn't even be a valid signature for it because it expires before the signature was made. So the actual time on your computer doesn't matter so much. In fact, I've tried that. I bumped my clock forward a couple years, and my computer still secure booted fine in Windows and Linux. So the future date doesn't seem to break anything. It's just that anything signed, you're trusting that Microsoft is only using valid dates to sign things. And again here, I can actually run mock, let's see here. If I want to run SB state, that's an easier way to, of course, tell that you're actually secure boot enabled. And of course, you can go all the different databases. I can see here's the revocation list. And all it is hashes of known broken bootloaders. So not a whole lot to see there, but if your bootloader matches one of those hashes, you won't boot.
Not in secure boot.
Not when secure boot's turned on. If the secure boot's turned off, there's no checking of your bootloader. Okay, so what happens when secure boot fails? I'll show you a couple screens here. So these are where I've got on different systems. When I tried to boot my bootloader, that's the error it got me from the BIOS. And here, this one's kind of hard to see, but you can see it's the path to the binders as error loading, EFI binary, shell. So those are just some of the errors you might see. So for my corporate laptop, it was originally given to me by my IT with Windows only. And while Windows is nice sometimes, I really do like using Linux at work. So I decided to see if I can get Linux dual booting on my work laptop. And I discovered initially it would not boot. It would always throw an error right away, and the error would usually disappear too quickly to see. So I went into the BIOS settings, and I discovered secure boot was turned on, and secure boot mode is user mode, but the key was allow Microsoft third-party UEFI CI. That was turned off. So this was in the off state, and because of that, even though that key is valid, it was not added to the database list. And so it was blocked from, it wouldn't approve my Linux bootloader, whether it was Fedora or Ubuntu. I couldn't boot anything but Windows. So I had to turn this on. And then when I turn this on and I reboot and I let Windows boot the next time, that's when I get my recovery key popping up, because I've now just modified my secure boot database. The DB database now has a new key, and Windows isn't expecting that. And you can also see my key state is called customized now. Technically, all I did was check a box, but I've customized the default list of DB certificates to allow third-party operating systems. And now all I did was my BitLocker recovery key one time, and then Windows was like, okay, this is your new PCR 7 state. I'll accept it. But it definitely scared me the first time I did this at work with my corporate laptop. But other than that, Linux installed, secure boot worked. I got all the drivers I needed on it, and I have a fully functional dual boot laptop for work. That's also IT compliant with.
I've noticed in fiddling with different machines that it seems to be very machine model specific. Some of them, if you do a factory default, it turns that on, and others it turns it off.
Yep.
It just doesn't seem to sense of
Yeah.
requirements to it.
No, and it's all what they put in those default variables, and they can put whatever they want in the default. They can throw Joe's Emporium certificates in there. I mean, who knows? It does vary from motherboard vendor to vendor, but ultimately, the majority of systems I've found do have some way of loading the keys you want. So I can go to full custom mode and not even have my Lenovo keys in here and just put in my own keys entirely. If I navigate around here, you'll see reset to setup mode, and then I can go in and change the keys however I want. So on my system, after I did this, you'll see that this is what it shows in the BIOS. I have my 2011 and my 23 KEC, and so this is all happened just from Windows updating naturally. And my DBs include, importantly, the UEFI, which is the third-party OS from both 2011, and also ThinkPad. This will boot ThinkPad OS, whatever ThinkPad provides as a firmware. It's probably like disk or BIOS updaters, but technically ThinkPad can also boot whatever they want on my laptop. Yeah, I do. Yeah, I do like Lenovo. This is another Lenovo system I have. This is an old ThinkCenter, and this one is an older computer that's no longer supported. It's old enough. It'll still run the latest Microsoft Windows 11 or Windows 10, and I got the latest updates through 2024, but it does not support Windows 11. So this is stuck forever on Windows 10, and it has no more BIOS updates past 2024 or something like that. I have the very latest BIOS on it, and it does not have the 2023 certificates. So I went in there, seeing if I can add it, and I can see I'm on user mode, so secure boot is enforced, it's enabled, but I can reset to setup mode, but when I do this, nothing else shows up here. I couldn't find any way to add the keys from the BIOS. Every other system I've worked on has worked this way. I can go to BIOS, it might be nice, it might be ugly, but I can add keys from here. In this case, even though I could just go to setup mode, I couldn't add the keys from the BIOS. But the important thing is once you're in setup mode, authentication of those variables is turned off. You can modify them, without any signature. Once I load a new platform key, though, you're back to user mode. So what I did is I booted up Arch, which by itself, of course, has no secure boot, and I loaded my own PK. So up here, I'll show you how to do that, but I created an authorized PK blob, which is just an X509 certificate I generated. It's called Secure Boot Demo PK. I was able to just run one command while I'm in setup mode, and I can read it back, and the variable's there. So there's Secure Boot, my own platform key, so I've now taken over full control of the system. And from there, once I load this platform key, I'm now in Secure Boot. If I were to reboot, Arch would not boot anymore. So the next thing I have to immediately do is then I have to load my key enrollment key, and this has to be signed by the platform key. So this is telling me which key it's signed by and loading that certificate in. That goes through fine. Then I load my DB, which is my end user certificate. So now I have all my 3 keys loaded for the trusted chain, and this DB key, this cert, I used to sign the bootloader. And I copied over, I replaced my unsigned bootloader with the signed one that I had signed offline. And on my next boot, I was able to boot in and get into Secure Boot on Arch Linux, which normally does not have a secure boot by default. So even though in the BIOS doesn't give you the options, as long as you can get to setup mode, that's the important thing. Then you can modify the variables from your OS and load in whatever platform key and chain of trust you want. So this system was now running an entirely custom chain of trust. And more importantly, at this point, once I did this, I can no longer boot Windows. Now, just to make sure I understood it, I did later use my key enrollment key, and I signed the Microsoft certificate, and I confirmed that I can sign Microsoft's DB certificate for Windows, and now Windows boots again. But I don't have the Windows KEK, only the Windows DB key, which is what signs the bootloaders. So they can't add more keys to me beyond the Windows key they already have added, but I can still boot Windows, and I can boot my Linux whatever with my own chain of trust and not have random certificates loaded.
So you create the platform key and the system crashes, what happens?
The worst case scenario should be that you go back to the BIOS, you click that reset back to setup mode. Yeah. As long as you can click this button in the BIOS, that wipes your PK from the BIOS. And then the general idea is user mode is supposed to still allow you to go to the BIOS and always reset your state. If you're in deployed mode and you lose your keys or something happens, you're stuck. So, but normally you don't bother with deployed mode. It's like only for the really secure stuff that you don't want to lock. But user mode, in theory, you should always have. I've always seen this somewhere in the BIOS, a way to reset back to setup mode, even on my corporate secured laptop. So on there, again, there's the reset to setup mode right here. So this has reset to setup mode. So even on my corporate Intel laptop, I can load my own keychain if I really wanted to.
I think on the HP stuff, you actually have to turn on BIOS passwords in order to get into it, because otherwise this part where you can turn on setup mode is grayed out if there's no password on the BIOS. I've seen stuff like that.
Okay, I mean, that might be within the realm of what they like to do, I'm sure. I mean, yeah.
I've seen a lot where
Yeah.
you have to have a password on it, and then the menu literally changes and there's more options.
Yeah, could be. I can believe that.
I had a bug once when I went into setup mode and after enrolling my own personal keys, the firmware just died on me and it would just boot loop. So I had to use the Lenovo's recovery image that somebody posted online to get my company.
Mm-hmm.
Then that wiped out all my my motherboard serial numbers and stuff. And I had to
Oh, yeah.
cover those up because it's a board.
Yep, yeah,
Exciting stuff.
I can believe that. So the other thing I will do is, even though this is Linux focused, for those of you that do have to work with Windows, you can force the update. So this was a separate test where on this same Lenovo box that no longer supported, and I was on Windows 10, I was able to force the secure boot to do the update from Windows. And that's because they still publish the keys signed. And so if you search online, so these will read the same variables I showed you in Linux, how to kind of read those variables in Windows. That's kind of a fancy script I have, but you'll see this line here. This modifies some registry value and sets it to value 40. This is what the majority of the online blogs will tell you to do. And then you run the scheduled task called secure boot update, which is some background task. And once it finishes, you should see your Windows 2023 CA loaded. But that thing is, this will only update that one certificate, which allows you to run newer Windows, not newer Linux or option ROMs.
But that's only in the DB, right?
That's only the DB update that this did here. So I found if instead of using 40, I turned on a few more bits, 5944. When I did that, and then I ran the same task, it updated every certificate in my chain, and I was fully up to date, even on a Windows 10. So
Where did you get the magic number?
a lot of Googling.
Yeah.
So someone knew the magic number. I don't know where it came from, but it worked. And here's a test script I found on a repo. I don't know if I have linked, but so this here shows the default, which is what the BIOS comes with. Of course, it has Lenovo as a platform key, but the default, of course, only has the 2011, not the 2023. And now I have the new 2023, so it did pull in the correct update, and this would have had to been signed by Lenovo's PK. So even though I'm on a no longer supported computer, apparently there was an update for the KEC, and ultimately I have all of the DB updates, including the UEFI one, which is the one. Actually, that's the Lenovo one. But yeah, this one right here, which is the one for Linux on all third-party OSs, and whatever Lenovo wants to include.
Lenovo must have used the same PK in every one of their, even the newer machines. If KEK that was distributed for 2023 worked.
Well, I did check the date on it. It does have an expiration date, but it's good for 20 years, not 15. So I don't know what's going to happen in a few years, but ultimately, I'm at least good until 15 years from 2023 as far as booting OSs. So
RAM prices should come down by then.
yeah.
So what happens if someone in the future finds some old machine in a retro gaming situation and tries to put this thing and it hasn't been updated? You're done.
Again, the worst case scenario, you reset the setup mode and you'll just generate your own chain of trust entirely from scratch. But let me get you some updates. I want to get you to the real meat. So first of all, here's the Linux version of that same thing, a little bit simpler. So, and I'll do this one as a live demo, a semi-live demo at least. So,
I copied the presentation.
yeah. So, and actually, I found you actually don't necessarily even need to do this as root. So I can run git updates, and you'll see here, it's a lot of output. But there it is. There's the KEC, and this is so it shows me my 2011 KEC with an update 2023. So there's my updated KEC for Microsoft if I want to apply that update. And then here, the UEFI one. Yep.
I found also at Intel that command does not work because they're blocked.
Oh, so you must have missed the presentation. Yeah, this is blocked by default at Intel. At Intel,
It looks like it's not blocked by Intel. It's blocked
no.
by
Yes, it's definitely blocked by the third party, by the hosting provider, because
no.
yeah.
Host your own stuff.
So yeah, and we do. We have Linux FTP. So we have an internal mirror of that entire service. So to do my update at work, I had to update a config file for FM update or whatever. Yeah. Yeah. So, but yeah, there is definitely a config file here. So we had to add a custom remote, I think is what it was. So it's the LVFS is the official. This is where these updates are coming from. This website is blocked by anyone who pings too heavily, which Intel definitely pings them too heavily. So I had to put in a custom remote that points to the internal company mirror in order to get my updates to come through. Once I did that, I got the updates. So yes, this is what I ran just the other day at work. And then once I get the updates, you just run update itself, and it's going to tell me. I'm not going to do this for now, just to minimize chances of.
You already put enough pain today.
Yes.
I've
But-
got a question. The get updates thing, is that the same as refresh? Or is that different?
I've been curious. I haven't quite figured that out yet.
Because I don't know what the hell there's I look at the damn dash help stuff, and there's 50 things. I just squint at it, and I pick something that.
Yes, I did refresh dash force, get updates, and a bunch of other commands. It took me forever to get it done at work. But what the recognition that they told me at work was you just have to run get updates followed by update. And from what I can tell, that should work as long as you don't have some weird block on your IP.
I want to say another experience I had was that the version of FW Update Manager on Ubuntu 24.04 seems to be different than the one on 26.04. That is, when I have a laptop with 24.04 on it, and I tried to update all that certificate silliness, and it wasn't there, wasn't available or something, and then I live booted 26.04. Here's all the kexts and stuff, and that all got installed. I don't know why
They
or
might
how or.
They might be having a different repo of updates that they
Well,
point towards.
Maybe, I don't know.
I-
It's just slightly bizarre to me. I didn't know what was happening.
I mean, I do know that there's some dbus interfaces that other programs can query it.
Yeah.
And I have a pop-up that pops up actually on my laptop that'll say, warning, you haven't updated your key yet on Linux.
Yeah.
Yeah, and so I have definitely seen that. Other programs. So another thing I want to show you here is I want to show you my EFI partition, at least a copy of it. So you can see just how secure boot is applied here. So this is your EFI system partition that you always have and don't do anything with. You'll see the Microsoft folder if you have Windows, and then there's boot and recovery, and here's all the files. So in theory, what needs to be assigned with the secure boot key is anything that is program code that runs during pre-boot. And that also technically would include your kernel and any kernel mode drivers that get loaded. So there's a command called from SB sign tools called SB verify, and you can list what keys each file is signed with. So for example, we can look at let's see here, boot manager.efi. I believe this is the main boot for Windows. And there it is. You can see the 2011 Microsoft production. And this is a pretty up-to-date Windows 11 computer on my laptop right now. This is Windows 11, and they're still on the 2011 key because this hasn't been updated since the expiration. So there's no need yet. This should still be valid even after the expiration of the certificates. But this is the Microsoft specific certificate, the production PCA, which is only for Windows. And you'll also see that even the DLLs, right, if I look at KD, Stub, or any of these others, because they're all program code, they're kernel modules, they all have to be signed by a key. So now if I go to where we really care about, Ubuntu or other Linux, you'll see files like this. So the biggest one you'll see is shim. This is because Linux changes a lot more, and there's a lot of verification that it takes to get bootloader signed. They don't want to sign grub. Grub's too complicated and changes too much. So what they do is they have an extra key they sign. Shim is a very small, well-known bootloader from Red Hat that has been approved by Microsoft, and inside of it, they can embed one key. That key is your distro key. So Red Hat has a key, Debian has a key, so on. Ubuntu Canonical has a key. So they'll each generate their own version of shim, and then they'll spend a bunch of money and take some time and have Microsoft and their Linux team go over the code and verify that it fits their policy, and then they'll sign this. So this doesn't change very often, but this is the root of the bootloader chain. In fact, if I look here at my bootloader status, so this will read all the boot variables in that EFI file system. And if I grep for boot, you'll see here the Windows Boot Manager, and you'll see, see right there, boot emgr.efi, which kind of split across the screen. But that's that file I showed you for Windows. And then for Ubuntu, it's shimx64.efi. That is the root of what the firmware boots. So this has to be signed by a trusted key in my DB. At that point, shim loads an additional key, which is the Ubuntu key. And so if I now run the same command and I look at grub, actually let's look at shim first. So if I look at shim, there it is, Microsoft Windows UEFI driver or UEFI CA 2011. So I still, again, I haven't updated for a while. But if I look at grub, that's signed by the Canonical Master Certificate Authority. So that's the key. This key was buried inside the shim, and so it gets trusted. But if I use Red Hat shim, this won't boot my system. So each major distributor has to have their own key signed and pay a bunch of money, and that's why Arch and some others don't have their own key. What I do have for Arch is if I want to try to stick with those keys, they have in the AUR database, shim-signed. It's actually a copy, I believe, of Ubuntu's shim. So we'll have Ubuntu's key built in, which doesn't help you with Arch, but the shim also allows you to add additional keys called mocks, or machine owner keys. Normally you would add just one mock, and then that's what you use to sign your NVIDIA driver, your own. Anytime you install a custom driver from some vendor that's not part of the standard Linux mod database, you can load it, you can sign with your own key called a mock and add that to the list of keys.
So what if you're building your own kernel? Do you have to sign that somehow?
Yep.
And you do that with a key you
Yeah,
generate?
and I mean, even with Arch, what I did is I created my mock,
Yeah.
and then I manually signed the Arch kernel with the mock.
Right.
So every time there's an update, it has to be re-signed. So either I can add a script to the kernel.d folder and have it, when you do make install, re-sign the kernel, but the downside is that kind of breaks the whole point of secure boot. Ideally, you'll have a password on it.
Is there like tooling in the infrastructure for the kernel?
Yeah, like if you're using like DKMS for Debian kernel module system, DKMS has some integration scripts that just work. You have to first run the mock utilities to set up your mock,
Right.
and then anytime you update it with DKMS, it'll re-sign the module as part of what the DKMS service. So in my system, for example, DKMS list. Wait, no, what is it? I haven't done this in a while. How do I list my? Let's see, isn't there a way to list what modules you have? Status, maybe that'll do it. Yeah, there it is. So you can see for example, on these keys, these are all being signed by my mock. Now, I don't actually have a password on my system because I'm lazy. So technically, if someone had root access to my machine, they could load whatever code they wanted.
Because the key's just sitting there on the hard
Yeah.
drive.
So ideally, when you generate your mock, you turn a password on.
Right.
If you're lazy,
Your password,
yeah.
unlock.
So the thing was, with the first time you load a mock, you just create your own certificate, whatever, and then you run a command to load it on next boot. What will happen is it adds it to a variable that it can write in the UEFI file system. When shim sees that variable exist on the next boot, it will start another program. So if you look here, in addition to grub, there's mmx64, that's the mock manager. This daemon gets run if the shim sees that you've set one of the mock variables to request a new key. It will then ask you, do you really want to add this key to your secure database, and it has this hash file? And then once you verify the hash matches exactly, you hit yes. And this only happens during this pre-boot state while shim is still running. So you're not yet exiting boot, what they call boot services, and you're in your OS. You can only modify the actual database in the pre-boot state. You can modify variables that request certificates from the OS, but not the actual database itself. And so the mock manager, which again, this is signed actually by the canonical key, just like grub is. So these two binaries can all be loaded, updated as much as they want. Only the shim is the one that has to be whenever there's an important update, gone through the whole process by Microsoft. So that allows you to load additional keys. And if I go here, mock util list enrolled, so that's the canonical master one. Ubuntu Secure Boot Module Signature. So I believe this is the one. Yeah, this looks like the right date. So this is the one that was generated. This is my mock. So it's known as its key 2. Key 1 is the one that's built into the shim, and key 2, this is the key that was generated as part of me setting up secure boot with the mock so that I could load my own kernel modules or my own custom kernels. You can sign your own kernel directly with this too. And everything in that's signed by this can be loaded during secure boot. Yeah.
So I noticed before there's something about Isle of Man. Yeah, there it is.
Yeah.
Okay, sure. Is that because there's like a moat around where they're holding the key?
I mean, well,
Not like water soluble paper or something.
Great Britain. I mean, I guess this is this.
It is a small island. It is a small island.
Small island.
Yeah. I mean, technically, I guess, yeah. Whatever Canonical decided to put into their. Well, let's see. So yeah, if you do want to do that, let's see here, hex.
Maybe that's where Joe is.
Oh, come on. There it is. Yeah. So that key is buried in the shim.
Yeah.
So that's just the key that they decided to bury in there when they had Microsoft sign their shim, and Microsoft didn't care. It's just a name.
Yeah.
So yeah. So yeah, that's the key that's trusted because it's already in the sign. So it's ultimately part of the chain of trust. But yeah, once you start adding your own machine owner keys, you basically taking the trust into your own hands, and if you don't take the time to secure your keys with passwords while your system's compromised at your own risk. So, but so if you need to do that, mockutil is ultimately the program you would use to do that. This will generate. So typically, what you do is you can. There should be an enroll somewhere in here. Generate, so trust mock. So trust mock enrolls the mock. You can untrust your mock if you want to go back to only the official keys. But yeah, this is the tool you'll manage if you need to load anything beyond the standard shim, or you want to use Arch. So for me, I got Arch working. In fact, let's see here. Might even have that demo. Okay. Let's see. So this is me playing with Arch and secure boot. Oh, that was quick. So, do I have a password on it? I probably used something stupid because it was just a test machine. Let me see here. Oh, man. Okay, there it is. I found it. Okay. So, but you will see here, if you look under boot, well, first of all, mockutil not installed.
Nope, it's not on there by default.
Well, this is what I had set up with secure. I forgot. Maybe I didn't use it. Maybe I used direct signing. So you can also just enroll a hash of a file. That's good if you just want a one-time kernel or you don't want to deal with certificates. The downside is every time the file changes, you have to enroll the new hash. So let me actually see if I'm pretty sure I'm in secure boot here.
Might be under SBIM, it's not.
Yep, secure boot enabled. So you also see here well, actually, let me show you something that's a little more interesting. Another setup I have, or I was playing with variables, is EDK2. Are anyone familiar with what EDK2 is?
Unfortunately, yes. As of this morning, also updated. So I have some questions about it for you.
Okay, so this is the kind of the UEFI development kit number 2. This is basically the reference platform for anyone making UEFI, and it allows you to compile your own version of UEFI that's entirely open source under some license. I'm not going to say whether it's OSS or whatever the certified but
It's quite liberal.
yeah, but yeah. So you can use this if you're building your own UEFI applications or things. I built 2048 using it. It's kind of fun to get that running in UEFI without native boot Linux. So, but you can build a full QEMU with secure boot enabled. So, yep.
Question for you. Do you know why by default the build disables the shell if you have secure boot enabled?
Probably because your shell isn't signed.
Because the shell itself isn't.
The shell is its own executable. Just like your bootloader, you have to sign it.
Got it.
And in fact, in order for me to do what I'm about to show you, I had to sign my bootloader first. Or I had to actually manually sign the shell executable. So if you look here, see here. That's probably capitalized. So yeah, that bootable, this file right here, I had to sign this in order for me to even load the shell once I had enabled secure boot on my system. So if you want to create your own keychain, by the way, my recommendation, my favorite, oh wait, I don't have internet. Okay. If you've ever used the Refined bootloader, they have a great article on UEFI, and they include a section on how to create your own keychain, how to generate the PK. Actually, I have the script here. So if I look at SB demo, so this is the script they basically had me run, and it's pretty basic. You know, this is, if you've ever generated certificates, this is your general self-signed certificate with some name. That you might have seen secure boot demo in my example screenshots. That's just me generating 3 independent certificates with keys, and then you have to convert them to DIR format. And then when you load them, you'll load them typically with a signature list. So this allows you to combine multiple certificates into a single blob for doing an update. And it just combines them into a single blob with a UID. And then, this is the more important part, you sign the blob. So this is what, once you're in secure boot, this sign blob, you might have seen me earlier loading a .auth file. This sign blob is what's signed by whichever primary key. So for example, my KEC is signed by the PK, the platform key, for my key enrollment key. This is what allows this key enrollment key authentication to be loaded once secure boot is enabled. So these two are how I load these 2 files after I've enabled secure boot. And it just verifies the chain of trust when I'm adding more keys. So if I wanted to add the Windows key, what I would first do is I would first get the Windows certificate, and more importantly, this actually has to be in PEM mode, PEM. So this is the, if you've ever dealt with certificates, you have DIR, which is like a binary format of your certificate, and you have PEM, which is an ASCII base 64 encoded version of the same thing. This script only works with the PEM version. And I screwed up my secure boot state on the first try because I've used the DIR certificate from Microsoft, because that's how Microsoft provides it, as a DIR file. So I had to convert it from DIR to PEM, which is the opposite of what I'm doing here on this line up here. This is me converting from PEM to DIR. You just do the opposite of that to get your PEM, and that's what this script expects. So I basically added the Microsoft certificate from their GitHub, put it into a signature list, and then I was able to sign it with my own personal DB key, or my own personal key enrollment key, I should say, and then load that into my system. So I have one system where I'm only running my own keychain, but I do have Microsoft Windows DB key, and I can boot Windows on it successfully, and it says secure boot is fully enabled. So you can still control your chain of trust and still decide to run Windows. But essentially, these are all just scripts from the EFI tools package, and it's all about taking certificates, putting them into a list, and signing them. And then they're now it's an approved update. And anything that can modify the EFI variables can send to the BIOS or the UEFI. Please load this, and as long as it's verified by the signature, it'll load. So that's why you can still update an old system as long as you have some chain of trust to go through. And so this here, okay. Let me just copy a command here. Let's see, ed. Okay. So this here is me running raw QEMU. So this does very little other than, all I have here is, this is for the hardware security check so that the firmware itself has a security check before it'll boot the firmware. That's a hardware mechanism that does that. Then I have the UEFI firmware compile that I compiled just a moment ago, the variable space, and the hard drive contents. So this is the most basic. And actually, I'm going to modify this slightly. Let's see here. I want to load the original variables, not the secure ones, for this test. Okay. Let's see. So here, so this is the EFI shell. Notice everything loads. So I can see my hard drive contents. I can even try to load a Linux, well, if I have enough RAM. But if I switch to the secure boot version, which I've already modified the variables to have my secure boot chain. Oh, I should just let the script run. You notice it failed to execute the binary, my hello world. So hello world, this is what happens when you don't have a properly signed binary. And when I originally did this, even the shell wouldn't run because the shell had not been signed yet. I had to sign the shell binary to get that far. So let's sign our binary. So I'm going to go to the hard drive contents, and there it is. I can go SB sign --cert, and the cert I created ahead of time is under demo db.crt, and I also need to give it the key that actually signs it with, demo db.crt, and then, see, is it just the file name next, I think? Yeah. Okay, that's right, so it's, and you give the input file, which is hello world, and then, oh, that's a mistake, yes. That should be the key. H2.efi. Okay. Yeah. Okay. So now I've signed it with my DB key that I've custom loaded. And, oops, I don't need to do that now. So go to FS0, ls, hello world, and it runs. And if I do, what's it? Yep.
So is it actually signed as a binary, or is it just simply inserted in the database table?
Nope, it is actually signed, and I'll show you that in a second.
So it's modified after that command?
Yeah.
Okay.
Let's see. Yes, okay. So
Can get out of Pocket, can get out of the shell.
first of all, well, look at the two files compared to each. Wait, oh, and versus the one on the hard drive. Let's see here. You'll see it's 2K larger, and if I go SB verify, we can list this file, no signature table. So there it is. I signed it with my secure boot demo DB.
Exactly, thank you.
Does it
Where
just
does
append
it-
that or
Hmm?
stick
Where
it
does
in
it put the,
front or?
in the actual binary?
Okay, well, if we want to go that level, we can do that. Let's see here. Oh, wait, it's not obj dump. I think we can do. The problem is this is not ELF. This is actually the PE cough that they use for EFI because it's Microsoft driven. So you have to remember how that works. So And let's see. In theory, I think there's a section you can see, but I know there is definitely in the Linux executable. What am I doing? Let's see. That's the .text. Huh. I think, let's see. Let's try all headers, I guess. See if it's in there. So in theory, okay, what should we have? Resource. Okay, so if let's set this to B, and then we will do this to A. Let's try this. Yeah. Okay. Okay, that doesn't matter. There it is. Well, security directory. That's what's modified. So there's a section called security directory that apparently is always there, and it now has contents.
Thank you.
Yeah. So yeah, there is a section in the executable somewhere. So, I guess any other questions or particular areas that of interest that people have?
You can't get to the BIOS.
I mean, if you can't get to the BIOS menu at some point, you do get kind of stuck. But let's.
The reason I ask is I have a old Mac Pro trash can, and
Oh.
I can't get to BIOS.
So if you're on a Mac, they do not use their secure boot. They have their own thing. It's a different. They have their own. They don't even use TPM. They have their own what they call it. There's a name for the enclave. They have their own enclave chip of some kind that's not TPM compatible, and whatever they do for secure boot. Last time I had to boot Linux, I had to go to like low security to get Linux to boot. I had to get to the recovery console. So there is no regular like BIOS menu on a Mac, but what I remember doing is I had to go to recovery, and if you like have a completely dead hard drive, they have an internet recovery mode that you can press a certain key combination to get to internet recovery. And I did this when I actually had to replace a hard drive one time and completely replace it. You get to that, it'll boot the entire recovery thing over Wi-Fi. So you log into the Wi-Fi from the recovery console, the BIOS loads, and then it downloads everything else, takes forever. Then from there, I was able to go in there and change the security level in the recovery console.
If you can still find them, there's also USB installers.
Okay.
That come by that are like essentially the same thing that it's doing but offline.
Yeah. Yeah, I do remember there was a time where I actually created a USB key for Mac OS a long time ago. I don't know, I got out of that. They were getting too locked down for me.
There's a nice GitHub project if you need old versions of Mac OS.
Well, I don't. What I mean,
You need to
I
purchase
just
something.
threw it away, or I don't even know if it had. I got it without, I think, Mac OS on it. I have just a pure Linux install on it.
I think it's Command R to get to the internet. That sounds right, if I remember right.
Yeah, Command R, I think, is recovery. Command Shift R might be the internet recovery. But yeah, something like.
So like the boot device.
Yeah, it's just the
powering
left
on with option.
Yeah.
Some keyboards don't work well, so you gotta have the right keyboard that works with the Mac OS firmware well. Sometimes Alt will not work if you're using a third party keyboard.
In my case, the Alt key worked, so that was. Yeah, I'm concerned that as time marches on, I'm going to be unable to update or something like that. But I suspect because Apple has basically terminated the line as of this year.
But the trash can is from 2013.
Probably, I don't know, somewhere in there. It's a 2013. It's one of the early ones, I think.
So I'll show you one more thing here. So if, let's say, you can't boot what you want because of this and you don't know where the keys are, this is how you would reset the keys if you needed to. So So exit here and get into the BIOS setup, EFI firmware setup, and this is the what they call OVMF, the Open Virtual Machine Framework version of basically EDK compiled for virtual machines. So if you have a secure boot UEFI virtual machine, whether it's QEMU or you can get something like this. So device manager, secure boot, and you can see I have secure boot enabled, attempt secure boot, and I'm in standard mode. So I actually preloaded my keys. I can go to custom mode, and here you can see it doesn't show me, actually show me which keys I guess are there. Or maybe, let's see if I go to enroll. Surprised it didn't actually show which keys I have loaded.
So when it says enroll, that's you're signing it somehow.
So enrolling it, so if I, first of all, let me reset my keys, so that should wipe that either.
Or you're adding it to a database.
Let's see. Oh,
K is a blast to deal with.
okay. But the idea is, let's say I want to enroll the keys that I've created. I can enroll it from a file, and I've done this either with USB drives on some BIOSes or by copying it to my ESP ahead of time somehow. There's usually some interface. And then here it is. There's my root file system. Here's all the files we've been looking at. No question, oops, it's a little slow. I don't know if the PEM one will work. Oh, if I commit. Yeah, so you have to use the dir for this. So enroll, PK, using file, select my drive. So this is my CER file version of it, which is the commit and save. And let's see. Now, and then I need to enroll my KEC. In theory, this is the one that is actually signed by the PEC, but because I'm still in setup mode, I think I can just load this directly. So technically, this is not a signed update, but I haven't entered secure boot yet. I'm going to hold off on adding this one yet. I want to see what happens. So if I do this, and I continue, and it's going to restart. In theory, it shouldn't load my shell. Actually, yeah, because I didn't load, and there it is. So the problem is I haven't enrolled my DB, the correct key for my shell. So right now I can't even get to, look at that, I can't even get to a shell. Just there, I broke my secure boot. So if you get to the state, then you have to go to secure boot at this point, because I have no way to recover with an empty DB. There's nothing I can boot. But in fact, so I have to reset my keys or go to custom mode, and then I can go here and reload my keychain. It's a little awkward interface. Why is this?
There's a PK key down below.
It's below.
Oh, why is this not? Okay, it's not sorted anymore. Okay. And then so now, okay, we'll commit and save that. Now this time I will load my DB, enroll using a file, and the DB that I assigned my shell with, oops, and commit and save. Okay, we can now, should be enabled. Go back here. We now continue. It's going to reset. And in theory, I should get back to my EFI shell. Up there it is. So the shell loaded, but because I restored my original hello boot, you can confirm secure boot is running because I can't run my hello world anymore. So that's how you would completely reset your keychain if you wanted to go with your own authority once you've generated all those keys with proper passwords in place and all that. So
Does it have deployment mode?
I have not seen that on the open source one. I have not found a way to do deployment mode there.
So,
Yeah.
when I heard about this, and this is very old news, but when Secure Boot was first being rolled out, Microsoft prohibited locking keys down on x86 systems.
There, I did see something about, you mean like how they can't lock out a third-party OS, or I did see something about to get the PC compliant logo, Windows PC or logo.
Windows, I think it was the Windows 8.
I think what they did is
Yeah.
they said they wouldn't certify a system as secure boot if there was no option to turn off secure boot.
Yes, I have seen that too. The thing is, the fact that we have Service RT says as long as the power is made by Microsoft.
ARM systems, they required it.
Okay, and that could be that because it's ARM.
Yeah.
So
And you listed all one ARM Windows systems out there, so there you go.
yeah,
All one.
yeah. So I do know, yeah. So that's like you said, secure boot can both be well.
We
Good,
don't talk about our thesis.
yeah. But yeah, I do think it's every x86 I've worked on so far, I've been able to configure the keys somehow. Usually I can do it in the BIOS, but if I can't, I have confirmed that even on an official Lenovo ThinkCenter box that I had at home, I could still do it from Arch once I had reset it to setup mode from inside the BIOS.
What I've seen is that all the BIOS seem to call everything something different. So you're like, they're in a different submenu.
Yeah, they all very,
So like, what the hell am I looking at here?
yeah, and
Just the uniformity.
mm-hmm.
Because they figure you're going to have like 10,000
Yes.
just the same machine.
Yeah.
Mm-hmm.
Well, in every generation, EDK changes something and you get a new look and feel for reasons.
Mm-hmm.
They went through several generations of S2600 systems and every damn BIOS was different.
Mm-hmm. Yep. So I guess, yeah, what,
I just have a bit of an FYI. I know you didn't really talk about looks and addition a whole lot, but chances are if you're doing rolling secure boot on Linux, you're probably using looks. And then you might think, oh yeah, well I'm good. I got looks. I got secure boot. I got password on my BIOS. It's fine. So there's actually like a small FYI tidbit. It turns out that if you enroll your Lux keys into your TPM, if you're not checking PCR 15, somebody can actually basically make replace your drive after it's been booted into an RD and make a copy of your drive and boot an illegitimate drive and get the key from the TPM because Lux doesn't actually check the integrity of your root file system. So,
yeah.
How would that work?
you'll have to look it up. It's
Yeah.
been a while since I've read it.
So-
There's something to know. So PCRs 1 through 7, I believe, are all handled by the firmware. After that, it's all specific to init RD, if I'm remembering
Yep,
correctly,
yep.
right? So if you're doing system D init RD, PCR 15 is what you have to look at for this.
Yep.
And that will actually verify that the drive that the TPM is passing the Lux decryption key to is legitimate.
Yep. And yeah, that's a whole topic. So that could be a future topic, just talking about TPM. I wanted to minimize that, other than you do realize there is an interaction with like secure boot, and it could without your recovery keys, you might not be able to unlock your loops or whatever. Yeah. So if you actually want to hear about TPM, I can go into that next. So, but yeah, I'm still trying to. I want to get my work laptop working correctly with that. At this point, I do have to put in a password on my work laptop on boot. But once I get that working properly, that will be a future talk, I think, as long as people are interested in that.
July 2nd is over.
Okay, I'll be in Alaska for a little bit. I'm not sure. I might be back, but I'll see what it is.
That's the day before, leading into the 4th of July.
Yep. But yeah, though it's really tricky to figure out the right stage. If you do want to do that, my preferred approach, I think, is looking at something called UKFI, where it creates a single unified EFI executable that has your kernel, your initRD, and a little stub bootloader. And then that whole thing gets signed as a single secure boot image, So that way you can verify that that entire thing is trustworthy with your own custom mock. And inside it, you also include the PCR policy of what it requires, and it will verify which PCR registers you think are important to verify your secure boot state in order to tell the TPM it can unlock the key for your encrypted root disk. But that's a whole topic, really. So.
Is there anything in an immutable Linux that might trip you up on this a bit? I don't have a lot of experience with immutables.
Yeah, like the silver blue and
Yeah,
stuff.
things of that nature, because those are.
Talk about that.
I can give you the NextOS kind of perspective because I roll my own secure boot keys. So there's a project for NixOS specifically, which is called Lanzaboot, which is a fork of system deboot. And what they do is every time you update, you basically re-enroll your keys and it'll sign everything up the chain. And so, yeah, it's a bit of a process to set up, and it doesn't even use the shim like Ubuntu or Red Hat does. But
I'm not even sure what the board is doing on this.
It's interesting because if you're using, with NixOS, it's completely configurable. So anything that you do, it completely trips up secure boots. We have to use their custom implementation of their RDS and their boot loader.
Oh.
The only other question, or not really a question, but a thought that came up with all this is if you're running FreeBSD or OpenBSD on any of your machines, none of this is really going to affect it because they don't even allow you to use
There used to be efforts in FreeBSD that I haven't had a chance to play with towards secure boot.
Right.
I did see a program called UEFI Sign. Maybe you know, Michael.
Well, you can self-sign, but
it's just like Arch, right? It'd be like Arch Linux or any of those. You're self-signing everything, but I do believe they put some efforts towards that with UEFI Sign and some other stuff that's part of FreeBSD 10.2 or.
FreeBSD's been doing a lot of stuff like that, but I'm wondering about like OpenBSD. I've been looking at it.
I don't think there's much there.
You're probably laughing at secure boot.
Yeah.
Well, they don't like it apparently. They think it's.
I mean, it's a lot to get right, and the thing is, ultimately, part of the problem is for a lot of people, if you can't get your key signed by Microsoft, then it's a somewhat moot point in some ways, unless you really want to run your own chain, and that's a very expert thing to do for a lot of people. But if you do that, you have to spend a lot of money. It's at least a few $100s, at least $400 or $500, I think, from what I saw, and it's good for a year. And actually, you might pay for each signing, but you have a $99 a year or something. There's some fee structure plus a few weeks of validation where they go over the code, verify it, and then sign it. And it's
I'm not running any things on bare metal. I'm running them as VMs mostly. But it's like it always crosses my mind. It's like is any of this going to even apply to some of this stuff?
Yeah, I mean, as I showed you, you can run a secure boot in VMs. Usually, it's not very common, but you definitely can turn that on. But it's also a lot easier to bypass secure boot in a VM if you can get outside the VM and break in. You can read all the RAM of your host from your host side of your VM. So it all depends on what your security threat model is.
Yeah, there's lots of them too.
Yeah, but I mean, if you're worried about someone logging in and loading a rootkit kernel module, it has some advantages there. I mean, that's basically it. There was one other thing I was going to add that I just remembered about modules. So one thing, if you do have to sign you want to sign your own kernel because you've built a custom kernel, you would do a similar signature to what I showed you earlier when I signed the EFI binary. But one of the questions that comes up is the kernel modules because they have to all be signed too. So what you'll actually find whenever you have a kernel modules, the typical setup is that they will actually generate an additional key that's used to sign all of the kernel modules. And that's if you have a default kind of kernel config, that's just turned on by default. You do your make, then every module that gets built as part of the built-in kernel modules will all be signed by this key that is embedded into the kernel itself. So the certificate's embedded in the kernel, not the key. And then what's very important, if you want to be secure, is afterwards you need to throw that key away because it's not protected. You don't want to leave that key sitting on your hard drive because otherwise, when someone breaks in, they'll find the key and then they can load modules into your.
Well, you're presuming a physical
Well, I mean, not physical. If someone gets root access, they can compile a module for your system if you have kernel sources around and load a custom kernel module on even on your virtual machine, right? You don't want anyone loading kernel modules that they've written themselves into your virtual machine Linux. So let me just show you something here. If I run dmessage, so sudo dmessage. So this is on a live laptop. Come on. What's the password? No. I do not have a caps key on here. My caps lock is always mapped to control on any machine I own. That's the only way to do it. Oh man, I have too many messages. Okay, maybe I can do this. It says no journal -b0. Good. Okay. Integ. I could have sworn. Actually, maybe I know my art should have it. In here, there should be. Well, somewhere usually there's a message that tells you which keys it's loading. I might be misremembering what the field name is. Oh, there, integ. Oh, so right here, you see platform keyring initialized, machine keyring initialized. So platform is all the keys loaded from the BIOS's keychain, and then all the ones that came with the kernel. And then right here, you'll see, in fact, here's what I'm looking for. Loading compiled in X509 certificates. And that top one says auto-generated kernel key. This was generated, and this is something that Arch does. So even though they come with an unsigned bootloader and kernel, they do sign the modules. And the certificate for those modules is buried in the kernel. So I only had to sign the kernel, and all the modules that came with Arch also loaded with secure boot, properly securing them. And if I loaded a third-party module that I built, I would still have to do an additional mock to load that. But you can see it's loading all of the ones from the BIOS as well as the auto-generated key that the kernel was compiled with. So whenever they build the kernel, ideally they're making sure they throw away that key after the baud and they don't release, it doesn't leak out at all. But that's something to be aware of if you do a custom kernel. You don't usually have to sign the modules directly because they're signed with that key if you don't turn that feature off. And you have to throw that key away if you want your system to be secure.
You just save it on your GitHub.
Yeah, yeah. So, but yeah, this is, yeah.
Yeah, right here, come and get me.
Okay.
So what happens to us in 9.5 to 10 years when Microsoft implodes and shuts their doors?
Yeah.
Well, I mean, to get a call comes out at some point, you might have to just load your own, create your own PK.
Yeah.
So as long as you can go to setup mode, you can load your own PK and your own chain of trust. So and maybe that's why they required that.
As long as they're making money signing stuff for people, they're not going to.
I mean, they'll spit off that division at worst case, right, or something.
So it's going to be Santa Cruz.
They won't they'll just make money by licensing it to other people, right?
Mm-hmm.
So this is vaguely related. Do you know about heads?
Hmm?
You know anything about heads?
Heads.
Heads. HEADS. It was some guy's project basically to do measured boot from like core boot all the way out.
Okay. I know there's a lot of talk about measured boot with.
Corporate already post that.
There's this. I don't know. All the details.
There's I forget where it is, but you can find it set that has measurements for that already.
If you look at there's a thing on the internet called Heads, and you can find out about it. I don't really know very much. It's a play on Tails.
Sure.
Okay.
But yeah, there's a lot of ways to do that. Like my team network measures that as one of our KPIs.
Yeah.
Mm-hmm. Yep.
to work with core boot.
So, well, so hopefully I was mostly understandable during this talk, but yeah.
I have two questions.
Okay.
One, is there a place we get the slides from?
Yeah. So, I mean, do I post it just to the mailing list, or is there a better spot?
Or
Or
have a link somewhere you can, or just
Well,
a PDF you can.
I mean, I should have. What I was going to do is I created a GitHub repo with the QR code, and I
And
didn't.
with luck, we'll have a YouTube video of this too.
Yeah. So,
You can read the little
I mean, I guess we can. You have a list of talks right on the website. You can have. I'll have a link for the website, maybe, or.
Yeah.
We've done that in the past. There's some PDF links in there. I looked at it today.
Okay. I mean, I'll
Email me something and
yeah. I hope to get this on some GitHub or something.
In my,
Especially because all these scripts of commands that I have too that I'm sure will be useful. I need to.
There's also on that same page a 2012 October talk from Vincent Zimmer about this new UEFI thing.
Oh.
I wonder if there's video.
Yeah.
It might be.
releasing videos.
Get that guy.
The carving of it.
My other question is there a good resource for learning more about the PCRs? Because you mentioned a bunch of levels, but there's some-
Yeah. Oh.
that seemed like a lot to unravel.
Well, if I had internet, I'd show you the website. But yeah, no. For me, I go to the original spec. The TCG Trusted Computing Group. They have a website with the TPM specs, and you can read in detail. But but no, I mean officially the first 7, the first 8 PCRs 0 through 7 are well documented, and assuming everyone follows the recommendations, which bootloader you use will tell you how 8 through 15 are used. The ones beyond 15 usually aren't used for anything. They're more for user, I think, used to. But different bootloaders like systemd boot uses some, Grub will use some, Shim has some that they use to measure different parts of the boot process. And you can kind of read about how those are loaded. But ultimately, the basic idea of a PCR is everything up to a certain point it hashes and keeps, and at any point you can add more to that hash. And it's basically a continuous SHA-256 hash that you can keep throwing more data into. And at the time you need it, it has to be a certain value. Otherwise, the TPM will not unlock the key for you. So the TPM has a master key that never leaves the TPM in theory, is generated inside the TPM, and from there it signs everything else, including encryption keys and all that. And the TPM will refuse to use its keys if the policy that's signed with that key does not match the PCR value. So the moment you change your secure boot and you don't, normally what you do is if you know your secure boot certificates are being updated, you should you do that from Windows. Windows will pre-calculate what the PCR should be, assuming this change is applied correctly. And then they will update some variable so that the next secure boot will work correctly. But if you update your secure boot certificates from Linux while you're doing booting, you might find you boot back into Windows and now all of a sudden it asks you for your recovery key. And Linux has the same thing. Whenever you install if you do use TPM unlock for your Lux encryption disk, it will calculate what the PCR should be, and if it's wrong, you'll have to use your recovery key or some other password.
Use your recovery key once or every single time you hop in there?
At least on Windows, once. On Linux, I think I've had to use encryption roll manually to re-enroll my TPM if it ever gets out of sync from my limited. But I need to. I'll play with it more before the next talk and to tell you what I found. So.
If you're a systemd person, there's a nice user-friendly command called bootctl, and if you're using systemd boot along with systemd init rd and systemd on your main distribution, then it'll give you like a really nice overview of what your secure boot status is and everything like that. And I think you can actually get like information about what all the PCRs actually are specifically and what they are shared.
Yep. And things can get really tricky when you think about all the things that you should secure at that point, because really your init.rd is one thing that's interesting. It's not secure boot signed because it doesn't load into the kernel. It's not a ring 0 code. But that means someone can modify your initRD because that happens. That's where your decrypting programs are, right? That's what actually mounts and unencrypts your drive. So you ideally want to protect your initRD if you're really truly security paranoid, and that's why a lot of even like Grub, it's really tricky to do it right. But as he says, Grub can do things like every file that Grub reads to load for booting, it will measure them into some PCR that will then be part of what is required to unlock. And so the TPM is also, that's why it's part of making it truly secure if you want to have an auto unlocking drive of some kind. Is you want to make sure that everything involved in the boot process has been untouched, and you're not unlocking your disk for some random hacker who's modified the initRD on the boot partition because it's not encrypted. Very complicated talk if you get into the details, I guess. So I don't want to get too deep.
Russell, you got another talk out of it.
So I guess, well, that's it. So, yeah.